Okay, now we are ready to go ahead and get started with turning sediments into rocks. So we're continuing the story of sedimentary rocks with lithification, which is the Greek term for turning sediments into rocks. Lithification is the process. It has two steps to it. First, you have to compact it, so you have to pack down the sediments and get rid of the space in between the particles. And the next step is cementation, or sticking it all together, otherwise known as like gluing it or something in a natural way. And those two steps make sediment into rock. So, if you think about it in this sense, how do you make a snowball? If you start with a snow and then you're trying to make a snowball, you do the same steps. You compact it tighter and tighter, and then what happens is that pressure that you're putting on the snow causes some of it to kind of melt, and that sort of holds a cement and keeps the snowball together. Because if you've noticed, there's certain temperatures at which it's better to make snowmen and snowballs, and sometimes it's not. The snow doesn't stick together or hold or cement really. And then the compaction doesn't seem to make a difference. So the same types of processes are going on in rocks. So first, compaction. Sediments, as we saw in the last little segment, they settle to the bottom of a lake, ocean, or river, and the energy drops and they settle out of the water. After a while, when you keep getting sediments, like it keeps snowing, for example, you can think of it that way, later sediments will pile on top of earlier sediments, and it just keeps going, and it builds up and up and up like a layer cake. So if you look at that picture, it's like one layer on top of the next layer, and they keep getting younger as you go up, building layer upon layer. If nothing disturbs them, they're going to pile up it horizontally. They're not going to be tilted or folded, and so they're going to look like that cake in the bottom where everything is a nice horizontal layer, and that is formed by gravity. So when you have gravity settling things to the bottom and nothing else, no earthquakes or tectonic forces or anything like that, they'll make layers. So it's very much like making a cake. So the best example of this is the island countries of, or the islands country of Malta. There's 3 islands in Malta, and all of them are made up of layered sedimentary rock. And the layers, as you can see, are nice and horizontal. It kind of reminds you of that layer cake from the slide before, because there's nothing to disturb them, no earthquakes or tectonic forces, and so they will simply layer, settle to the bottom of the ocean, and then build up over millions of years. And so this is basically what the geology of all of Malta looks like, all 3 islands. And so now you can say you know something about the geology of Malta. It's layered sedimentary rocks, and it's horizontal, and the oldest material would be down there by the water there at the bottom, and then the youngest material would be at the top, what is still being deposited to this day. So the second step after you compact everything is you want to cement it. So cementing sediments into a rock requires some glue, basically. So some natural glue or rock glue is 3 different things, and there are the chemical formulas there. So there's a silica cement. This is like quartz. Quartz is the best known form of silica, and so you've probably seen quartz around. It's usually a white or a clear rock, and that makes the hardest cement of the 3. Calcite cement is the softest of the 3, and that's calcium carbonate. That's the CO3 there is carbonate structure. And that one makes a cement that is a little bit softer than quartz, and also it will react with something like vinegar and it will actually fall apart. Sometimes fossils, animals in past life will contribute to this calcite cement. And then the last one is iron cement, and that is two iron molecules. Fe is the chemical symbol for iron, with three oxygens. So that's iron oxide, and that is better known in a slightly different form, but still using iron and oxygen, as rust. And so that will turn rocks red. And a little goes a really long way. If you've ever seen any red rocks, now you can say that you know something about how they're cemented. They're cemented with iron, iron oxide. So we're going to do glue today to make our own rocks with the layers of material that we collected. And so just out of curiosity, what's the chemical formula of glue? Just regular old Elmer's glue. And that has carbon in it. So it's somewhat like the calcite cement because you can see there's a carbon in that too. It binds with oxygen. This one is just kind of by itself. But then there's hydrogen, and then there's oxygen, just like the calcite cement again. The carbon and the oxygen bonded together in a carbonate structure. This time it's in a different structure. It's in a carbon, hydrogen, and oxygen structure, and that N is that it can be in a different number of formations. And so that is the chemical formula of glue. So we're going to be using a glue cement on our rocks. There are other chemical reactions going on with limestone. If you're wondering what happens with limestone, if you add calcium carbonate is also limestone. So it's not only a cement, you might have recognized that chemical formula from before. It's not only a cement, but it's also a rock. So that, and if you add water and carbon dioxide to it, it will break down. And so the chemical weathering process is, it'll break down into calcium and carbonic acid. And it will also go the other way. If you have some calcium dissolved in seawater and some carbonic acid, you can also form limestone. So in the seawater, when it's saturated with respect to calcium, and there's too much to be dissolved and it starts settling out, it will combine and form limestone. So that reaction goes both ways. Sandstone is a slightly more complex formula, but not that bad. You still start with, if you can recognize there's that cement and the limestone formula, calcium carbonate, water, CO2, that's H2O, CO2 is carbon dioxide, and H4, that's 4 hydrogen atoms with a silica structure. You can kind of see the SiO4 is close to SiO2, which is quartz, and that will yield quartz, SiO2 on the other side of the equal sign, and calcium, carbonic acid, and water again. So that one, both ways it goes, both the weathering and the formation of sandstone, is you produce water. Water goes into it, water comes out of it. And then there's quartz and also some calcite cement as well. Then there's iron oxide cement. That is, as if it's all by itself, it is known as the mineral hematite, and that's 2 iron atoms to 3 oxygens. So that's the Fe2O3. It turns rocks red. So less than 2% of iron oxide will be enough to rust the rocks. So in that picture there that was taken just east of Laramie, that a little goes a long way. So less than 2% of iron oxide will rust those rocks. So that completes turning rocks into, or turning sediments into rocks, and the lithification process. And now what we're going to do is we're going to cement our own rocks. And so in this next segment, we will use some glue and do some creative things with our layers to make sedimentary rocks. Thanks. Okay, well now we have assembled all of our material, and what we're going to do is we're going to go through the process of lithification, which is both compaction and cementation by using these everyday materials. So As you can see, I've got everything that I cut to or tore to the approximately the right size before. What I'm going to do, because this is kind of a sneak peek into what we'll do in the next session, is I'm going to divide everything into 2 piles. So I'm going to put this here, that there, and then I'll kind of divide up the magazine pages into kind of 2 piles. Then what you want to do, and because I'm doing this in 2 piles, the reason why is that we're going to do flower pressing or leaf pressing or once living material pressing. And how we're going to do that is we're going to put it in between 2 layers of rock. So even though lithification is a 2-step process of compaction and then cementation, usually it goes in that order in the natural world, but we're going to do it in a slightly different order, in that we're going to cement it together first and then we're going to compact it. So to do that, just take any old glue that you've got around the house. Elmer's school glue works as good as any, and then start with your bottom layer, your oldest layer. Put some glue around it, just enough to use some cementing material. And like we talked about in that video, this glue is a mixture of carbon, hydrogen, and oxygen items. Then cement it with your next layer and keep going until you've got all the layers. So I'm going to take a minute now that you kind of have the idea of what you want to do. And then I'll come back with once everything is done, and we'll go from there. Thanks. All right. Well, we took a few minutes and we glued every layer together. So as you can see on this side, there's magazine or catalog pages in there, and then there's some cardboard. You might want to end with a cardboard on both your piles. On this side, I did a little bit more of an interesting thing. I've got the cardboard on the bottom, but then I took a piece of tissue paper and crinkled it up and then just kind of glued it over the top, and then put the next layer on there. What I'm going to do is then, like a sandwich, going to let these 2 things dry, and then we're going to put our organic material on this layer and then put this on top of that, and then we'll compact it. So take a few minutes and then we'll pick up again in the next session with flower pressing or pressing our organic material. And in the meantime, just kind of keep these in an undisturbed place until the glue dries.